used to seeing the streams of vapor left in the wake of planes. But as we've been hearing in the news, they can also leave a data trail, a stream of data that monitors the plane's performance. At the headquarters of Rolls-Royce in Derby, engineers make nearly half the world's passenger jet engines, including this, the TRENT 1000, the engine that powers many of our transatlantic flights.
The temperatures in the back of the engine are staggeringly high. I mean, we talk about the temperatures being half of the temperature of the surface of the sun. In fact, it's 200 degrees above the melting point of the metals that we use. And the only reason they don't melt is because we pass cooling air through special passages and channels that keeps the gas away from touching the metal.
The engine is full of vital components, all engineered with absolute precision, including an onboard computer.
This relatively unassuming box is the brains of the engine. Not only does it control it, but it also performs another crucial function.
It receives data from sensors buried deep within the engine, measuring 40 parameters 40 times a second, including temperatures, pressures, and turbine speeds.
All of the measurements received by the computer are stored and then streamed via satellite back to base here in Derby.
And that's not just true for the TRENT 1000, it's the same for the entire fleet. That's thousands of engines.
A Rolls-Royce powered engine takes off or lands every 2.5 seconds, somewhere in the world.
That's a very cool factoid, isn't it? And whenever they are up in the air, there is information coming back about the functionality of this engine back to Derby, to here.
Absolutely, and they're constantly monitored using clever data analytics that are looking for anything going wrong in the engine or any sign that it might need to be serviced early or something like that.
So wherever you're flying to, while you're 30,000 feet in the air or higher, thousands of streams of data are constantly sent back to base. Here, computers are programmed to sift through it for any anomalies.
So you've got 11 engines that have flagged something up on your system. That's not necessarily an emergency, but something that needs to be looked at. Is that how it works?
Yeah, absolutely. And just an example, this has been flagged due to that step change in the value for this oil pressure parameter of around 10 psi. So when we start to see something that is not what we would expect to see, that's the first trigger point.
And then that's when you guys step in.
Absolutely, yeah.
Analysts here take a closer look at any problem data and get on the phone to the airlines immediately. The result? Technical faults are dealt with before they become a major problem, preventing delays. Plus, the working life of the engine is dramatically improved.
One of these engines will fly around the world 450 times before it needs to be overhauled. That's a hell of a mileage.
And just as big data works for plane engines, it can also work for healthcare